This is worksheet 5 of the States of Matter packet, and in this worksheet we are going to put together what we know about electronegativity and the electronegativity chart with what we've learned about the 3 types of intermolecular forces in this packet. So you will need to refer back to the electronegativity table that's on worksheet 3, so make sure you have that handy. And you're going to want to pay really close attention to this bonding forces chart that you're looking at right now. I'm going to show you how to use this chart on this worksheet, and this chart is going to be provided on your next test. Now, what I've highlighted in yellow is what will be on your chart on the test. Okay, basically, all these little hints that are in parentheses, along with the examples in the farthest right column, are going to be removed. But otherwise, this chart will be on your test. Okay? So what this chart does is it shows you that if you can calculate the difference in the electronegativity values, those numbers from the chart on worksheet 3, between 2 atoms in a molecule, then you can determine both the intramolecular forces that are holding the individual atoms together, along with the intermolecular forces that are holding multiple molecules together. Right? So remember that the intramolecular forces, those are the stronger ones. So that's, is it a covalent bond or an ionic bond? And the intermolecular forces are the more broad-ranging ones that are a little bit weaker, the dispersion force, hydrogen bond, and the dipole-dipole force. Okay? So let's go ahead and look at some of the problems. We'll do a couple together and you'll finish the rest on your own. Okay? Question 1, for all of the molecules that it gives you, it wants to know the intramolecular force. So for question 1, we're going to be looking at this column here. Alright? So let's use CH4 as our example. Okay? If you look back at worksheet 3, you can see that carbon has an electronegativity of 2.5 and hydrogen has an electronegativity of 2.1. So if I subtract these, I see that the difference in electronegativity is 0.4, right? Carbon pulls harder on electrons than hydrogen by 0.4. So if I take this 0.4 number and I go up to my chart, okay, 0.4 falls in this range here of 0 to 0.49, which means that the intermolecular force, oops, sorry about that, here, I was just trying to erase that, yikes. Can I erase? No. Okay. Which means that the intermolecular force, if I'm in this 0 to 0.49 row, is nonpolar covalent. Okay? And so that's what you're going to write down here. You're going to say that this is a nonpolar covalent bond, meaning that they're sharing electrons. Well, we kind of already knew that because we had 2 nonmetals, right? But not only are they sharing electrons, they're sharing them really evenly. If we were to draw a picture of the carbon and the hydrogen, we could place the electrons kind of right smack dab in between the 2 of them, not one closer to the other. Because although there is a difference in the electronegativity of carbon and hydrogen, 2.5 versus 2.1, it's not enough of a difference to really make a difference in terms of who can pull the electrons closer. Alright, so you're going to do similar things for all the other compounds in question 1. Alright, but let's go on to question 2. Okay, if you do a little comparison, question 2 is asking you to look at all the same molecules, but this time it wants to know the intermolecular force. So if you had, for example, 2 CH4 molecules, what would be the force holding those whole molecules together? So you're really going to do the same calculation. I mean, you can look back at worksheet 3, and carbon's still going to have an electronegativity of 2.5, hydrogen's still going to be 2.1, and so the difference is still 0.4. So you don't really need to recalculate. You could just refer back up to this calculation up here. Okay? Then you're going to use that 0.4, you're going to go back up to the chart, right? So once again, you're in this range, and now we're trying to figure out the intermolecular force, and so we look over here and we see that it's a dispersion force. Okay, so there's not a constant dipole, a constant like kind of negative, kind of positive side to this molecule. It's just nonpolar. And so it only relies on those sort of chance happenings where the electrons just happen to move in all the right ways, creating this dispersion force. Okay? So that's pretty much what you're going to go ahead and do, and I think you can try to fill out the rest, and we will look at your answers when you get to class.